Okay, here we go. Today's lesson, you're going to spend the next 3 days on it. So the worksheet that you get today is the only worksheet you'll receive over the course of the next 3 days. Are we all clear? Raise your hand if you're gone Monday for National Honor Society Field Day. Oh, raise your hand if you're gone Tuesday. Okay, so between those 2 days, I will just cover one lesson. We all good? You ready? Kaylee's ready. Here we go. Here's the big question of the day, folks. How do we take the antiderivative of, I mean, that's kind of what we're doing right now, right, is taking antiderivatives. Yesterday we showed you some really unique ones. For example, if I said, 1 over the root of 1 minus x squared, the fact is that a lot of people look at that problem, they're totally confused. But you guys know that antiderivative, right? What is it? Yeah, exactly. You're like, well, that's super easy now. So, no big deal. So once you recognize the forms, things work out. And if we happen to, put a 4 minus 4x squared, you just factor out 4, right? And you do some basic substitution, and, life would be good. Great. I'm glad that you see that. But what about this? What about the integral of x sine of x dx? What's different about that? It's a product rule. It's like you're trying to undo the product rule, right? So so right now you look at the x, you're like, well, that'll be like x squared over 2, and sine of x, that'll be like negative cosine of x. And you're like, okay, well, that's it, So like, look at me, Mr. Gantz. And I say, well, if you think that you're correct, why don't you try checking your answer? How would you verify your answer? What would you do with this? You'd take the derivative. And you know that if you take the derivative, you must use the product rule, right? Well, product rule would be the derivative of the first part, which would give you x squared times then cosine, right? And then minus x squared over 2 times the derivative of cosine, which would be negative sine. So you end up with, like 4 pieces, 2 terms, right? That doesn't work at all, does it? So what do we do? We do integration by parts. Thank you, Braden. He's got it. You see, we know that f times g prime is f prime g plus g prime f. Is everybody with me there? Everybody good? Okay. What we're going to do is we're just going to put in big F for little f. What is big F compared to little f? The antiderivative, right? So, but we're just going to use as a variable in this situation to represent the function. And so what we have here is if big F goes in for little f, then we have big F times little g derivative is equal to, let's see if you guys can get this. If I put big F in for little f, then what goes in for f prime? Little f, yep. Plus g prime of, or g prime times big F. We all good? All right. Well, now what I'm going to do is I'm going to take the antiderivative of everything. Okay? So I've got the antiderivative of big F times g prime, which equals the antiderivative of f times g plus the antiderivative of g prime times big F. Ooh, very interesting. What is the antiderivative of big F times g prime? What happens to the integral symbol and the derivative? They go away because they are inverse operations, right? So we end up with this expression. Big F times little g is equal to the integral of f times g plus the integral of g prime times big F. Now I'm almost done. Nope. It would have to be of both of them. So what we have here is we have the integral of of two things multiplied together. See, that's what I was trying to do at the beginning, wasn't I? The antiderivative of two things multiplied together. So this would be like function f, and this would be like function g, correct? So it's sitting right here, isn't it? So all I'm going to do is just subtract that piece on over. And I get big F times little g minus the integral of g prime times big F. And that's equal to the integral of f times g. Kind of written backwards, so we're going to write it forwards. The integral of fg is equal to big F little g minus integral of g prime big F. And it's a beautiful thing. It's super helpful. Jake, Carter, can you concur? Helpful? You concur that it was helpful to have seen the little bit of it that we did? Yeah. Exactly. Okay, so we're trying to set you guys up in situations to succeed as you move forward into your Calculus 2 world. So what do you look for when you do this? Number one, G is something you derive. F is something you what? What's that? So we get to this piece, the antiderivative of x sine of x dx. We're going to make it super easy. Are you ready for super easy? Good. Let's do super easy, okay? G is something you derive. Do you know the derivative of x? Do you know the derivative of sine? Cosine. So it looks like G could really be either one. Let's think about F. F is something you antiderive. Do you know the antiderivative of x? Squared over 2, antiderivative of sine, negative cosine. So it looks like F could be either one as well. So when you know the derivative of both and you know the antiderivative of both, here's what we do. We choose G to be something that when you take the derivative, it just kind of eventually goes away. So do you see how when you take the derivative of this one, it cycles around and around and around and around? When you take the derivative of the x, it just goes away, right? So I'm going to call this G, and I'm going to call this F. Is everybody okay with that first step? So I have the integral of x sine of x is equal to, and I look at my rule for integration by parts. Integral of fg is equal to big Fg minus integral of g prime big F. That's the rule that I use. We didn't make it up. I proved it for you right on the board. It took a whole 3 lines. So now we go. What is big F? Negative cosine of x. What's little g? So I have negative x cosine of x. Is everybody good with that? Minus the integral of, what is g prime? 1. What's big F? So positive cosine of x dx. G is x. But so we have little g. Big F is negative cosine. Better? on this one because I forgot and I'm not perfect. Negative x, cosine of x. Shoot, now I got another integral. Should we give up? Why shouldn't we give up? And it's super easy. What's the antiderivative cosine? Because we have a minus sign, but big F was negative cosine. Oh, no. Natural log of x. What's the antiderivative of natural log of x? Everybody goes to 1 over x. That's the derivative, folks. That's the derivative. You don't... You looking at your sheet? Cheater, Chris. Sometimes you come across a antiderivative that you don't know, and it doesn't look like integration by parts is going to help you, but in fact, integration by parts will. The key is to choose f to be something you take the antiderivative of, and g to be something you take the derivative of. Well, let's look. Natural log of x. You don't know the antiderivative, but do you know the derivative? What is it? So therefore, natural log of x is g. Now I just need to come up with f somewhere. Unfortunately, there is nothing for f. So it's 1. Yep. There's a 1 in front of the natural log, right? What is little g? Natural log of x. What's big F? Why? Because the antiderivative of 1 is? So there it is. Then what? Minus integral of 1 over x times x dx. So I have x natural log of x minus the integral of 1 dx. Oh no, I have another integral. Should we just quit? We should probably just quit, shouldn't we? X natural log of x minus x plus your constant. That's the antiderivative of natural log. Isn't math awesome? It's funny, when I say math is awesome, I can look at all of your expressions, and some of you kind of give me this glazed over look. And some of you are nodding like, oh yeah, it is. I'm with you, Mr. Gens. Thank you for supporting me on this day. I appreciate it. You try example 3 on your own. Go. All right, YouTube Nation, we went over that one together. You can check it out. That's the work. Two more problems. Integration by parts. We got two things that are multiplied together. See if you can identify which one should be F and which one should be G. You know the antiderivative of each, and you know the derivative of each. It does matter. So in that case, you choose G to be the one that will eventually go away. The derivative of 3x squared is 6x. The derivative of 6x is 6. Derivative of 6 is? No, derivative of e to the x is, and then derivative of e to the x is, and then the derivative of e to the x is, and then the derivative of e to the x is. You want to continue to play this game? It's really fun. What if I gave you a problem on a test and I said, what is the 1,856th derivative of e to the x? All right, here we go. Integral fg is equal to big F little g minus integral g prime big F. Boom. Time to roll. What is big F? Okay, I'll rewrite it. 3x squared e to the x dx equals, what's big F? E to the x. What's little g? Hey, that's the same stinking thing, isn't it? My grandma's got more attitude than you. What's that? You can deal with it. Minus integral 6x e to the x? Honestly? All right. Yeah, so Chris sees it. We don't know that antiderivative. It's another integration by parts, isn't it? So I'm going to have to decide which one's F and which one's G, which is which. Yep. So we'll do it again. 3x squared e to the x minus parentheses. I'm going to use this. So the rule says big F little g. So it's still going to be 6x e to the x, correct? Minus the integral of, what is g prime? 6 e to the x dx. I will explain. So this guy right here, we're going to do this with it. Because we don't know the antiderivative of 6x e to the x. We're going to have to use integration by parts again. So as you can see here, big F is e to the x, and little g is 6x. Minus integral g prime. G prime is 6. And big F is e to the x. The good news is you know the antiderivative of 6e to the x. What's the antiderivative of 6e to the x? 6e to the x. We have 3x squared e to the x minus parentheses 6x e to the x minus the antiderivative of 6e to the x we said was just 6e to the x. Distribute the subtraction sign, and we get 3x squared e to the x minus a 6x e to the x plus 6 e to the x plus a constant. You're finding the antiderivative of 3x squared e to the x. No, I found the antiderivative. The antiderivative of 6e to the x is 6e to the x. Yep. Because the derivative of e to the x is e to the x. The antiderivative of e to the x is e to the x. So the antiderivative of 6e to the x is just 6e to the x. Well, now my integral symbol is gone. So I have this expression. Distribute my subtraction sign, and I get this. without a doubt, many times you don't have to do this, but many times people do write the final expression as 3 e to the x times x squared minus 2x plus 2. So that would be often the way that the answer is written as you factor out your common factor of 3 e to the x. You sure can. You should distribute your subtraction sign through. Yes. But it only works in certain situations. So Chris is one step ahead. So on Monday and Tuesday next week, picture if you had this, x to the 10th e to the x. Well, then you would understand that you would have, x to the 10th, you would have 10x to the 9th, you would have 90x to the 8th, you would have 270x to the 7th. Like, it would take a while for that to go away, wouldn't it? So there's a pattern that develops, and I'd be happy to show you the pattern on Monday. Where? What did I put 2 cents? Oh, it's 720. Sorry. You had to check that on your calculator? Wow. Okay. Okay, let's look at this one. Integral e to the x cosine of x. Last example. What's that? G, you want to be cosine of x. This is interesting because in this situation, you know the antiderivative of each, and you know the derivative of each, right? Okay. So that's what I have. Do I have one that eventually goes away? I don't. So this is going to be a little tricky for us, but very doable. And so what I choose in this situation is, would you rather take the derivative of e to the x or cosine of x? All right, how about this? Would you rather take the antiderivative of e to the x or cosine of x? So I'm going to choose f to be e to the x because I like taking the antiderivative of that one. I don't like to take the antiderivative of cosine. I would rather take the derivative of cosine. All right, what do I start with? Because it's big F times little g. Then I have cosine of x minus, then what? The derivative of cosine is negative sine. Alex is perceiving exactly what's going to happen. He says, oh no. Now we end up with something very similar, don't we? It does just go on forever. So we just say no solution and quit, right? No! What's big F? What's little g? Or what's little f? What's little g? All right, let's try it again. Use my parenthesis just in case. So I have big F times little g. Okay, so I have big F, which is e to the x, and then little or g prime, which is going to be cosine of x dx. Isn't it interesting that you came up with an integral that we started with, didn't we? That is wild. So we're gonna just write this out once. We're not gonna actually do that part. We're just gonna write it without parentheses. And as I write it out slowly, I'm gonna try. They don't cancel. Stop saying it. Like when I hear you say it 10 times, like if I don't say yes, right, nice job, you're onto the right spot. Like, no, it doesn't. All right. So resist. Okay. Chris is correct. He sees the situation here. He says, hey, I've got something here and I've got the same thing over there. I have an equal sign in between. Are these two things not like terms? So you could just simply add 1 to both sides. Oh my gosh. So how many of these do you now have? 2 times the integral of e to the x cosine of x dx. So no, they don't go away. They double. It's literally what you were trying to say. Okay, thank you. Sorry for not giving you credit. Hey, I don't want to know what 2 of them is equal to. I want to know just what 1 of them is equal to. So let us divide by 2. And if we factor out the e to the x, we get 1/2 e to the x times cosine of x plus sine of x plus a constant. Riley, did I make a mistake? I expect that you know how to do every problem that we're doing in class and then on your notes. Yes, definitely. Sure. I do know what you're talking about, and I will accept it. All right. So we do this is level 1 integration by parts. Okay. This is basic. Okay. We aren't going to get to like level 3 type stuff, but we will do a little bit more difficult stuff, and we're going to look at that Monday and or Tuesday depending on who's here and who's not. You're not going to get a new assignment that day. I will hand you the worksheets, just you're not able to do all the problems right now. Okay. So I wanted to get this day in. I thought about giving you a work day today, but the fact is that because people are going to be broken apart on Monday and Tuesday, we needed to get this in at this time. Okay? Good job, folks. I'm very proud of you. And no, they do not cancel.